Good morning, students. Am I audible, visible? Write in the chat box. Abhinash BJP Higher Secondary. Gayatri BJP Higher Secondary. Higher Secondary. Shivani Ansala. Good morning. So today we'll start a new subtopic on sequence and series, that is geometric progression, right? I've done geometric progression. Geometric progression or GP. Geometric progression or GP. Write down a sequence is called a GP. If the ratio of a turn not the first turn. If the ratio of a turn, not the first turn, and its preceding turn remains same, throughout the sequence. A sequence is called a GP if the ratio of a term, not the first term, and its preceding term remains same throughout the sequence. A1, A2, A3, A4, up to AN are in GP if A2 upon A1 is equal to A3 upon A2 equals A4 upon A3 equals An upon An minus 1. Okay. And the ratio is known as common ratio of the sequence. The ratio is called common ratio of the sequence. The ratio is called common ratio of the sequence. Quickly note it down. Now write down general form of a GP. General form of AGP. If A be the first term, and R be the common ratio of AGP, if A be the first term and R be the common ratio of AGP, then the sequence is given by, then the sequence is A, AR, AR square, AR to the power n minus 1. AR square, AR to the power n minus 1. So nth term Tn of the sequence is AR to the power n minus 1. This is the formula to find out nth term of a GP. If the first term of the GP is A and common ratio of the GP is R. Write down a question. Find the 20th term of the sequence Find the 20th term of the sequence 2, 6, 18, 84. The GP is given by 2, 6, 18. First four terms of the GP are given. 2, 6, 18 and 54. We have to find out the 20th term of the GP. Okay. Here the first term of the GP is 2. Find the common ratio. Common ratio is the ratio of the second term and first term, or third term by second term. Quickly calculate it. Two into 3 to the power 19. Okay, let me calculate. Come to the solution. Here A is equal to 2. Common ratio R is equal to 3. T20 is equal to AR to the power n minus R. AR to the power 20 minus 1. AR to the power 19. 2 into 3 to the power 19. Yes, Gayatri, you are correct. Rukti Women's Higher Secondary Basudevpur. 232452 2934. Okay. Okay, let's write down the sum of n terms of a GP. Sum of n terms of a GP.
Gamra.
ପିଲାଙ୍କୁ mute କରନ୍ତୁ। If A be the first term, and R be the common ratio if A be the first term and R be the common ratio of a GP, then the sum of n terms is that is Sn is given by Sn is equal to A whole into 1 minus R to the power n upon 1 minus R. Sn equals to A whole into 1 minus R to the power n upon 1 minus R. Okay, come to the explanation. A is the first term and R is the common ratio of the GP. So Sn is equal to A plus AR plus AR square plus up to AR to the power n minus 1. So multiplying both sides of the equation by R, will get R times Sn will be equal to AR plus AR square plus AR cube plus up to AR to the power n minus 1. The last term will be AR to the power n. Okay. Now the subtract the second equation from the first equation. Equation 1 minus equation 2, Sn minus R times Sn is equal to A. AR cancels, AR square, AR to the power n minus 1. What are the leftover terms? A and AR to the power n is equal to A minus AR to the power n. We can take A as common, AO times 1 minus R to the power n. So 1 minus R times Sn is equal to A times 1 minus R to the power n, implies Sn is equal to A times 1 minus R to the power n upon 1 minus R. Sum of n terms Sn is equal to A times 1 minus R to the power n upon 1 minus R. Quickly note it down. Okay. Write down a question. Find the sum of first 15 terms of the sequence 2, 8, 32, 128, and the sum of first 15 terms of the sequence 2, 8, 32, 128. Here A is equal to 2. The common ratio R is equal to 4. So S15 is equal to A whole into 1 minus R to the power 15 upon 1 minus R. So this is equal to 2 into 1 minus 4 to the power 15 upon 1 minus 4. This is equal to 2 upon 3 into 4 to the power 15 minus upon 1. Then come to sum of an infinite GP. Sum of an infinite GP. Sum of an infinite GP. If A be the first term, and R be the common ratio, of a GP, if A be the first term and R be the common ratio of a GP, such that R mod less than 1 and the number of terms is infinite and the number of terms N is infinite, then Sn is equal to A upon 1 minus R. If A be the first term and R be the common ratio of a GP such that R mod less than 1 and the number of terms N is infinite, that is N tending towards infinite, right? So sum of N terms of a GP, the formula is Sn is equal to A whole into 1 minus R to the power N upon 1 minus R. If the value of R lies in the interval minus 1 to 1 and N tending towards infinity, if you increase the power of a quantity which lies in the interval 0 to 1, if the power approaches to infinity, then R to the power N approaches to 0. Okay. So Sn will be A upon 1 minus 0 upon 1 minus R is equal to A upon 1 minus R. So infinite power of a quantity which lies in the interval minus 1 to 1 approaches to 0. So R to the power N becomes 0. Sn is equal to A upon 1 minus R. Is it clear to you? Write in the chat box, is it clear? Okay, then come to properties of a GP. Write down properties of a GP. Just a minute, guys. Properties of geometric progression. Property 1. If each term of a GP is multiplied by same constant quantity K, if each term of a GP is multiplied by same constant quantity K, then the resulting sequence is a GP. If each term of a GP is multiplied by same constant quantity K, then the resulting sequence is a GP. Let us consider the GP AR square up to AR to the power n minus 1. Now multiply each term of the GP by K, it will be K. Then the second term will be K into R. The third term will be K into R square. And the nth term of the sequence will be K into R to the power n minus 1. Here the ratio of the second term and first term is R. Ratio of the third term and second term is R. Ratio of the nth term and n minus 1 term is R. So common ratio is maintained and the sequence is a GP. Okay, then come to the second property. If each term of a GP is divided by same constant quantity, if each term of a GP is divided by same constant quantity, then the resulting sequence is a GP. Then the resulting sequence is a GP. Come for the explanation. Let us consider the GP AR square to AR to the power n minus 1. Now divide each term of the GP by same constant quantity. Let the constant quantity be K. Dividing each term by K, it will be A times K, A by K, A upon K times R, A upon K times R square up to A upon K times R to the power n minus 1. Okay. The ratio of the second term and first term is R. Ratio of the third term and second term is R. The ratio of the nth term and n minus 1 term is R. Common ratio is maintained and the sequence is a GP. If the common difference is maintained, then the sequence is AP. If common ratio is maintained, then sequence is a GP. I hope it is clear to you. Is it clear? Write in the chat box. Okay. Then come to property 3. The term of a GP are selected at a regular interval if the terms of a GP are selected at a regular interval the terms of a GP are selected at a regular interval and formed a sequence then the sequence is a GP. Okay. Let us consider a particular GP 2, 4, 8, 16, 32, 64, 128, 256. Okay. So select the terms after one term, suppose 4, 16, 64, 256. So this forms a sequence and this is also a GP. The terms of a GP are selected at a regular interval and forms a sequence, then the sequence is a GP. Then come to property 4. In a GP, product of the terms in a GP product of the terms equidistant from beginning and end. In a GP, product of the terms equidistant from beginning and end remains same. In a GP, product of the terms equidistant from beginning and end remains same. Let us consider the GP A, AR, AR square, AR to the power n minus 3, AR to the power n minus 2, AR to the power n minus 1. Okay. Now multiply the first term from the beginning with the first term from the end. Their product will be a square times R to the power n minus 1. Now take the product of the second term from the beginning and second term from the end. Their product will be a square. R into R to the power n minus 2 will be R to the power n minus 1. Product of the terms, third term from the beginning and third term from the end. A into A will be a square into R square into R to the power n minus 3 will be R to the power n minus 1. Okay. So product of the terms equidistant from beginning and end remains same. Then come to property 5. If A1, A2, A3 up to AN are in GP, then log A1, log A2, log A3 up to log n are in FP. If A1, A2, A3 up to N are in GP, then log A1, log A2, log A3 up to log N are in FP. Come for the explanation. Let the GP be AR, AR square, ARQ up to AR to the power N minus 1. Taking the log of each term of the GP, it will be log A, comma log AR, log AR square, log ARQ, log AR to the power N minus 1. Log AR to the power N minus 1. Log A, log AR square, log ARQ up to log AR to the power N minus 1. Will give you log A, log M into N is equal to log M plus log N, and log N to the power N is equal to N log M. So the first term will be log A, second term will be log A plus log R, third term will be log A plus log R square is equal to 2 log R, log A plus 2 log R, and fourth term will be log A plus 3 log R, and the last term, that is the nth term, will be log A plus N minus 1 times log R. Okay. What is the difference between the second term and the first term? Difference between the second term and the first term is log R. Difference between the third term and the second term is log R. And difference between the third term and the fourth term and third term is log R. Similarly, the difference between the nth term and N minus 1 term is log R. Common difference is maintained. Now we can say that the sequence is an FP. I hope it is clear to you. So guys, write in the chat box, is it clear? Okay. Then come for the next property. That is your property number 6. If A1, A2, A3 up to AN are in GP, then A1 to the power K, A2 to the power K, A3 to the power K, up to AN to the power K is also a GP. If A1, A2, A3 up to AN are in GP, then A1 to the power K, A2 to the power K, A3 to the power K up to AN to the power K is also a GP. Let us consider the GP AR, AR square, ARQ up to AR to the power N minus 1. Now, taking the K power of each term of the GP, it will be A to the power K. The second term will be A to the power K into R to the power K. The third term will be A to the power K into R to the power 2K. A to the power K into R to the power 3K up to A to the power K into R to the power N minus 1 into K. Alright. The ratio of the second term and first term is R to the power K. Ratio of the third term and second term is R to the power K. Ratio of the fourth term and third term is R to the power K. Common ratio is maintained. Now the sequence is a GP. Then come to property 7. The product of corresponding terms of two GPs, the product of corresponding terms of two GPs always determines a GP. The product of corresponding terms of two GPs always determines a GP. Let us consider the two GPs AR square up to R to the power n minus 1. This is the first GP. BS square up to BS to the power n minus 1. This is second GP. If you take the product of corresponding terms, then that will be the first term will be FB, second is FB into RS, third is FB into R square FB RS whole square, and the last term will be FB into RS to the power n minus 1. Here the common ratio is RS. Ratio of the second term and first term is RS. Ratio of the third term and second term is RS. Common ratio is RS. Common ratio is maintained, and the sequence is GP. Is it clear? Please write in the chat box. Is it clear? Okay. Then come to property number 8. The ratio of corresponding terms of two GPs is also a GP. The ratio of corresponding terms of two GPs is also a GP. Let us consider two GPs. Let first GP be AR square up to AR to the power n minus 1. Let the second GP be BS square up to BS to the power n minus 1. If you take the ratio of the corresponding terms, then it will be A upon B. Second term will be A upon B times R upon S. Third term will be A upon B times R upon S whole square. And the last term of the sequence will be A upon B times R upon S to the power n minus 1. Hence the sequence is a GP. Okay, this is all about the formulae and properties of a GP. Nth term so far, what we have discussed, the nth term of the GP is equal to Tn is equal to A whole into 1 minus R to the, Tn is equal to AR to the power n minus 1 Sn Sn is equal to a whole into 1 minus r to the power n upon 1 minus r, and sum of infinite Gp is a upon 1 minus r, and all these 8 properties. Okay. Okay, let us come to discuss couple of questions asked on JEE Mains. Recent year JEE Mains questions, 2025 and 2024. Write down a question. If the sum of the second if the sum of the second, fourth, and sixth term of a GP and sixth term of a GP of positive numbers is 21, and the sum of eighth, 10th, and 12th. 8th, 10th, and 12th term is 15309, 15,309. Find the sum of first 9 terms. Find the sum of first 9 terms. So guys, take 2 minutes of time and try to solve it. If you won't be able to solve, then I will discuss it. Okay. Try to solve. Easy question. 1 by 26 into 3 to the power 9 minus 1. Gayatri, you have to write the answer because should I tell you the options? The options are 760, 750, 757, and 755. These are the options available. Okay, you have to choose the correct option. 757 is the correct answer, guys. 757 is the correct answer. Okay. So, guys, let me explain. Let A be the first term and R be the common ratio. So, sum of the second term will be AR plus fourth term ARQ and sixth term AR to the 5 is equal to 21. If you take AR common, AR times 1 plus R square plus R to the power 4 is equal to 21. And what is the second? Second is sum of 8th, 10th, and 12th. AR to the power 7 plus AR to the power 9 plus AR to the power 11 is equal to 15,309. So this is equation 2. This implies AR to the power 7 times 1 plus R square plus R to the power 4 is equal to 15,309. This is your equation 2. Now dividing equation 2 by equation 1. Equation 2 dividing equation 2 by equation 1 will get AR to the power 7 into 1 plus R square plus R to the power 4 upon AR times 1 plus R square plus R to the power 4 is equal to 15,309 divided by 21. Okay. This term cancels out. A cancels R to the power 7 by R will be R to the power 6. Okay. Dividing 15,309 by 21, it will be 729. So implies R is equal to 3. Okay. R is equal to 3. Now substitute the value of R in equation 1, you will get the value of A. If you substitute R is equal to 3 in the equation 1, so 3 into A times 1 plus 9 plus 81 is equal to 21. So this is 7. A is equal to 7 upon 91. R is equal to 3 and A is equal to 7 upon 91. We have to find out the sum of the first 9 terms, S9. S9 is equal to A whole into R to the power N minus 1 upon R minus 1. A is equal to 7 upon 91 into 3 to the power 9 minus 1 upon 3 minus 1, which is equal to 757. Okay, this is the answer. A is equal to, okay. Should we go for the next question? Okay, a good question. Mixed question on FP and GP. Write down that. X1, X2, X3, X4 be in a geometric progression. Let X1, X2, X3, X4 be in a geometric progression If 2795 are subtracted respectively from x1, x2, x3, x4, then the resulting numbers are in AP. Then the resulting numbers are in AP. And 1/24 into x1, x2, x3, x4. Hello. Pranam ko Pranita. Okay. If let x1, x2, x3, x4 be in geometry progression, if 2795 are subtracted respectively from x1, x2, x3, x4, then the resulting numbers are in AP. Find 1/24 x1, x2, x3, x4. Yes, Gayatri, 216 is the correct answer. Two hundred 16 is the correct answer. Okay, guys, come for the solution. Let the GP be A, AR, AR square, ARQ, X1, X2, X3, X4. This is X1, this is X2, this is X3, and this is X4, right? So we have to subtract 2, 7, 9. So A minus 2, AR minus 7, AR square minus 9, and ARQ minus 5. These are in AP. If these three terms are in AP, so if ABC are in AP, twice of the middle term is equal to sum of the extreme terms. So 2 times AR minus 7 is equal to A minus 2 plus AR square minus 9. It is one of the equation involving A and R. So these three terms are in AP. So 2 times AR square minus 9 is equal to AR minus 7 plus ARQ minus 5. Okay, solving these two equations. So 2 equations, 2 unknown. Data is sufficient. Now you can handle it. Okay. Okay, let's move forward to the next question. A is equal to minus 3 and R is equal to 2. We have to find the product. The product will be A to the power 4 into R to the power 6. We have to calculate A to the power 4 into R to the power 6 upon 24. Next question. Let A1, A2, A3 be in GP. Let A1, A2, A3 be a GP of increasing positive numbers. If A3 into A5 is equal to 729 and A2 plus A4 111 upon 4, then find (24) times A1 plus A2 plus A3. Solve it. Answer असला yes, 129, the correct answer. Let me explain it. Let the GP be A, AR, AR square. Okay. A3 into A5 is 729. This implies what is A3? AR square, and A4, 5 will be AR to the power 4 is equal to 729. So A square R to the power 6 is equal to 729. This implies ARQ whole square is equal to 729. This is equal to 3 to the power 3 to the power 3 to the power 2. So ARQ is equal to 27. Okay, this is equation 1. Again, A2 plus A4. A2 is AR, A4 is ARQ, 111 by 4. So ARQ is equal to 27. AR is equal to 111 by 4 minus 27. Okay. This is equal to 3 by 4. This is equation 2. So dividing equation 2 by equation, so equation 1, this is. Equation 1 by equation 2, ARQ upon AR, 27 by 3 upon 4. This is equal to 36. So R square 36 implies R is equal to 6. If R is equal to 6, then A will be 3 by 4R is equal to 1 upon 8. Okay. Now you can get the value of 24 times A1 plus A2 plus A3. Clear? Twenty-four times A1, that is 1 upon 8. A2, 1 upon 8 into 6. 1 upon 8 into 36. The value is equal to 129. Guys, your first session is over. Take 5 minutes of break. Then we'll start the second session. We'll solve some good questions on JEE Mains and JEE Advanced. Take 5 minutes of Check who are present. Gayatri is present. Jasmine, KHSS, Purushottam, Snehavari, Sudhanshu. Okay. Abhinash. Well done. Some important points. The important first point. 1 plus 2 plus 3. So first write down sigma notation. Sigma or summation means continuous addition. Sigma summation means continuous addition. Sigma R is equal to 1 to N AR means if you take R is equal to 1, it will be A1 plus A2 plus A3 and the last value of R is N, that is AN. Sigma R is equal to 1 to N AR is equal to A1 plus A2 plus A3 up to N. Second, sigma I is equal to 1 to N AI plus BI equals sigma I is equal to 1 to N AI plus sigma I is equal to 1 to N BI. Sigma I is equal to 1 to N AI plus BI is equal to sigma I is equal to 1 to N AI plus sigma I is equal to 1 to N BI. Come for the explanation. Message. What is the message? Good morning. Vivo, what's your name? Your name is not Vivo V2437. Write your name and college. Like Gayatri is writing Gayatri Behra, BJP Higher Secondary School. Okay. So I think Vijay sir. Sir, namaskar. Then come to the explanation. Sigma I is equal to 1 to N AI plus BI is equal to, if you take I is equal to 1, it will give you the first term of the series A1 plus B1. If you take I is equal to 2, it will give you the second term of the series, that is A2 plus B2 plus up to AN plus BN. You can rearrange the terms like all the 8 terms will be taken together. A1 plus A2 plus A3 plus up to AN plus of B1 plus B2 plus B3 plus up to Bn. A1 plus A2 plus A3 up to An. This is equal to sigma I is equal to 1 to N AI plus sigma I is equal to 1 to n bi. Sigma I is equal to 1 to n ai plus sigma I is equal to 1 to n bi. Okay. Then third one is sigma I is equal to 1 to n ai minus bi equals to sigma I is equal to 1 to n ai minus sigma I is equal to 1 to n bi. Quickly note it down. Then next point, sigma I is equal to 1 to n k times ai is equal to k times sigma I is equal to 1 to n ai. Then fifth one, sigma I is equal to 1 to n ai plus k. Sigma I is equal to 1 to n ai plus k is equal to sigma I is equal to 1 to n ai plus k times n. Come for the explanation. Sigma I is equal to 1 to n ai plus k equals a1 plus k plus a2 plus k plus a3 plus k plus up to an plus k. This is equal to a1 plus a2 plus a3 plus up to an plus k plus k plus k up to k n times k. This is equal to sigma I is equal to 1 to n ai plus n times k. Okay. Sixth one is sigma I is equal to 1 to n ai into bi is not equal to sigma I is equal to 1 to n ai into sigma I is equal to 1 to n bi. Sigma I is equal to 1 to n ai into bi is not equal to sigma I is equal to 1 to n ai into sigma I is equal to 1 to n bi. Where sigma r is equal to 1 to n r is equal to 1 plus 2 plus 3 plus up to n equals n into n plus 1 divided by 2. Sigma r is equal to 1 to n r square equals 1 square plus 2 square plus 3 square plus up to n square is equal to n into n plus 1 into 2n plus 1 divided by 6. n into n plus 1 into 2n plus 1 divided by 6. Sigma r is equal to 1 to n r cube is equal to 1 cube plus 2 cube plus 3 cube plus up to n cube is equal to n into n plus 1 by 2 whole square. Okay. After calculation, you have to remember all these formulas. Okay. Fourth one is 1 plus 3 plus 5 up to 2n minus 1. So sigma r is equal to 1 to n 2r minus 1 is equal to n square. Okay. Write down a question. Find the sum of the series. r upon r plus 1 factorial. Guys, try to solve these questions. First one is 3080. Okay, let me check. Okay. The first question is 1 into 2, 2 into 3, up to 20 into 21. Come to the solution. 1 into 2 plus 2 into 3 plus up to 20 into 21. This is equal to sigma r is equal to 1 to 20 r into r plus 1. This is equal to sigma r is equal to 1 to 20 r square plus r. This is equal to sigma r is equal to 1 to 20 r square plus sigma r is equal to 1 to 20 r. So n into n plus 1 into 2n plus 1 by 6. N into n plus 1 21, 2n plus 1 41 upon 6 plus n into n plus 1 divided by 2. Now you can handle it. Okay. Then come to the question number 2. 2 more messages. Whole square into n plus 2 divided by 12. This is for second question. Okay. Let me calculate. So quickly note it down. Question number 2 is 1 square into n plus 2 square into n minus 1 plus 3 square into n minus 2 plus up to n square into 1. 1 square into n plus 2 square into n minus 1, 3 square into n minus 2 up to n square into 1. This is equal to sigma r is equal to 1 to n r square into n minus r plus 1. Okay. This is equal to sigma r is equal to 1 r square into n plus 1 minus 1 minus r. This is equal to sigma r is equal to 1 to n r square into n plus 1 minus sigma r is equal to 1 to n r cube. Okay. And this is equal to n plus 1 into sigma r is equal to 1 to n r square minus sigma r is equal to 1 to n r cube. This is equal to n plus 1 n into n plus 1 into 2n plus 1 by 6 minus n into n plus 1 divided by 2 whole square. Now I can calculate this. Come to question number 3. One upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon 3 into 4 plus up to 1 upon n into n plus 1. The series is known as telescoping series. The series is known as telescoping series. এই সিরিজ রে পিলে কোন করতে মানে লেখি লেখি কাটନ୍ତି ମୁଁ ଏବେ ତ ଲେଖି ଲେଖି କଟା ଶିଖେଇବି ବଟ୍ ଡାଇରେକ୍ଟ ଆମେ ଶିଖିବା ଡାଇରେକ୍ଟ ଲେଖିବା ଲେଖି ଲେଖି କରି କାଟିବାନି ଆକୁ ଆଗେ ଲେଖିବା ସିଗ୍ମା r is equal to 1 to n 1 upon r into r plus 1. This is equal to sigma r is equal to 1 to n r plus 1 minus r upon r into r plus 1. This is equal to sigma r equals to 1 to n 1 upon r minus 1 upon r plus 1. Okay. एट पिला माने कोन सब गोटी गोटी लिखिबे तापर काटिबे आर जगह 1 दबा 1 minus 1 by 2 plus आर जगह 2 दबा 1 by 2 minus 1 by 3 plus आर जगह 3 दबा 1 by 3 minus 1 by 4 m सीरीज चलला plus सबको आर जगह n देले 1 by n minus 1 by n plus 1 तापर सब सीरीज m सब काटिबे हमको लेख लेख काटिया पड़िबोनी पिले मन रखो तो सिग्मा नोटेशन तुम टेलीस्कोपिंग लगाइबो हला कि upper function should get the upper value and lower function should get the lower value. Here the upper function is r plus 1, lower function is r. Upper value should be given to the upper function and lower value should be given to the lower function. If we take r is equal to 1 to this function, it will be 1. Minus upper value should be given to the upper function, it will be 1. Okay. This is equal to n upon n plus 1. Got it? Function with higher argument should get the higher value and function with lower argument should get the lower value. Function with higher argument should get the higher value and function with lower argument should get the lower value. This is the rule, right? Then what was the next question? Sigma r is equal to 1 to n r upon r plus 1 factorial. Sigma r is equal to 1 to n r upon r plus 1 factorial. Okay. Sigma r is equal to 1 to n r upon r plus 1 factorial. This is also a telescoping series. This is equal to sigma r equals to 1 to n r plus 1 minus 1 upon r plus 1 factorial. This is equal to sigma r equals 1 to n r plus 1 upon r plus 1 factorial minus 1 upon r plus 1 factorial. So r plus 1 factorial divided n factorial by n is equal to n minus 1 factorial. This is equal to sigma r is equal to 1 to n divided 1 upon r factorial minus 1 upon r plus 1 factorial. This is the higher argument, this is the lower argument. So upper value, higher value should be given to the higher argument and lower value should be given to the lower argument. This is equal to 1 minus 1 upon n plus 1 factorial. Okay. So let's start with question asked in JEE 2025 telescoping series. Find the sum of first 20 terms. JEE 2025. Find the sum of first 20 terms of the series four into one divided by 4 plus 3 into 1 square plus 1 to the power 4 plus 4 into 2 divided by 4 plus 3 into 2 square plus 2 to the power 4 plus 4 into 3 upon 4 plus 3 into 3 to the power 2 plus 3 to the power 4 plus 4 into 4 upon 4 plus 3 into 4 square plus 4 to the power 4. Okay, this is the series. And this is a telescoping series. Try to solve it. Solve କରିପାରିବ ପିଲେ ନା ମୁଁ କରିଦେବି? So the series in summation form can be written as आंसर आया है शायद 210 by 211. Let me check the answer. 210 by 211. Answer sent by Gayatri. No, Gayatri, it's not a fractional number. It is a whole number. Oh, sorry. So the question is, yes, I think you are correct. I have not written the full question. If sum of the first 20 terms is equal to m by n, sorry, if the sum of first 20 terms is equal to m upon n, where m and n are relatively prime, then we have to find out the value of m plus n. So 210 by 211. Yes, your answer is correct. You are correct. Okay. The series can be written as sigma r is equal to 1 to 20. Sigma r is equal to 1 to 20. 4r upon 4 plus 3 times r square plus r to the power 4. This is equal to sigma r is equal to 1 to 20 4r upon r to the power 4 plus 4r square plus 4 minus of r square. This is equal to sigma r is equal to 1 to 20 4r upon r square plus 2 whole square minus of r square. This is equal to sigma r is equal to 1 to 20 4r upon r square plus a square minus b square, a plus b into a minus b, r square plus r into r square minus r plus 2. Okay. And the difference of these two will be 2r. So this is equal to sigma r is equal to 1 to 20 2 times into 2r upon r to the power 4 plus r square plus 2 into r to the power 4 minus r square plus 2. Right? This is equal to 2 times sigma r is equal to 1 to 20. Difference of these two is 2r. So r to the power 4 plus, oh, not r square, it is r. Sorry. So r to the power 4 plus r 2 minus r to the power 4 minus r plus 2 upon r to the power 4 plus r plus 2 into r to the power 4 minus r plus 2. Okay. This is equal to 2 times sigma r is equal to 1 to 20 1 upon r square minus r plus 2 minus 1 upon r square plus r plus 2. So higher function should get the higher value and the lower function should get the lower value. So 2 times lower, if you put r is equal to 1, this will be 1 by 2 minus If you take R is equal to 20, 422, this is equal to 2 times, this one will be 422 for 211 minus 1, 210. This is equal to 210 upon 211, which is equal to m by n. M and n are relatively prime. So m plus n is equal to 210 plus 211 is equal to 421. Okay, this is the answer. I hope it is clear to you. Write in the chat box, is it clear? Is it clear? Avinash? Gayatri? Gayatri answer, correct answer. Yes. So this part is over. Now let's move forward to arithmetic mean and geometric mean. Come to arithmetic mean. If ABC are in FP, then B is called arithmetic mean of A and C. Then B is called arithmetic mean of A and C. That is B is equal. So if ABC are in FP, then 2B is equal to A plus C. So B is equal to A plus C by 2, which implies that arithmetic mean of two numbers A and B is given by A plus B by 2. Arithmetic mean of two numbers A and B is given by A plus B by 2. Second point, arithmetic mean of n numbers arithmetic mean of n numbers A1, A2, A3 up to An is given by A1 plus A2 plus A3 plus up to An upon N. This is equal to sigma I is equal to 1 to n AI upon n. Clear? Okay. Then come to n arithmetic means between two given numbers. N arithmetic means between two given numbers. N arithmetic mean between two given numbers. So we should discuss it like a question. Insert n arithmetic means between A and B. Insert n arithmetic means between A and B. Come to the solution. Let x1, x2, x3 up to xn be n arithmetic means let x1, x2, x3 up to xn be n arithmetic means between A and B. Let x1, x2, x3 up to xn be n arithmetic means between A and B. This implies A, x1, x2, x3 up to xn and B are in FP. Okay. So B will be the n plus 2 term. N terms plus AB 2 terms, n plus 2 term. So T n plus 2 is equal to B. You know, nth term Tn upon P, A plus n minus 1 into D, where A is the first term and D is the common difference. So Tn plus 2 is A plus n plus 2, n plus 2 minus into D is equal to B. So this implies n plus 1 into D is equal to B minus A. So D is equal to B minus A upon N. D is equal to B minus A upon N. X1 is equal to A plus D. This is equal to A plus B minus A by N. X2 will be A plus 2D. This is equal to A plus 2 into B minus A upon N. And Xn will be A plus n minus 1 into, A plus nd, not n minus 1. A plus nd, this is equal to A plus n into B minus A upon n. x1 a plus d, x2 upon, oh, b minus a upon n plus 1, not n. b minus a upon n plus 1, b minus a upon n plus 1. This will be b minus a upon n plus 1. Okay. Is it clear? Did you understand, guys? Write in the chat box. Okay. Write down a question. Insert five arithmetic means. Insert five arithmetic means between 2 and 32. This is the question. Five, 10, 15, 20, 25. Acha. Let the five arithmetic means be x1, x2, x3, x4, x5. Let x1, x2, x3, x4, x5 be the five arithmetic means. Then 2, x1, x2, x3, x4, x5, and 32 are in FP. So 32 is equal to a plus n minus 1, a plus, that is 2 plus 6d. So d is equal to 6d is equal to 30, implies d is equal to 5. If d is equal to 5, then x1 will be 2 plus d, 2 plus 5, that is 7. X2 will be 2 plus 2d, that will be 12, then 17, then 22, then 27. These are the five arithmetic means. Gayatri, I think you are wrong somewhere. Okay. Next question. If a to the power n plus b to the power n upon a to the power n minus 1 plus b to the power n minus 1 is the arithmetic mean of A and B, then find the value of n. If A to the power n plus B to the power n upon A power n minus 1 plus B power n minus 1 is the arithmetic mean of A and B, then find the value of n. N is equal to 1. Yes, you are correct. N is equal to 1. Okay, let me explain it. If A to the power n plus B to the power n upon A power n minus 1 plus B power n minus 1, you can use heat and trial. In a heat and trial, the arithmetic mean of A and B is A plus B by 2. If you take N is equal to 1, the numerator will be A plus B and denominator will be A to the power 0 plus B to the power 0. A to the power 0 is 1, B to the power 0 is 1, 1 plus 1 is 2. So by heat and trial, you can solve this question. But if you want to solve it in actual method, then you have to solve like this. A to the power n plus B to the power n upon A to the power n minus 1 plus B to the power n minus 1 is equal to A plus B upon 2. Okay. Now cross multiplication, it will give you A to the power n plus 2 times B to the power n is equal to A times A to the power n minus 1, that is A to the power n plus A into B to the power n minus 1 plus B into A to the power n minus 1 plus B to the power n. So A to the power n, 2A to the power n. 1 A to the power n cancels. B to the power n, 2B to the power n. 1 B to the power n cancels. So A to the power n plus B to the power n, A B to the power n minus 1 plus B A to the power n minus 1. Okay. So A to the power n minus A into B to the power n minus 1 equal to B into A to the power n minus 1 minus B to the power n. If you take A as common, A times A to the power n minus 1 minus B to the power n minus 1 is equal to B times A to the power n minus 1 minus B to the power n minus 1. Okay. If you take A to the power, now you should bring this term into the left hand side and we will take A to the power n minus 1 minus B to the power n minus 1 as common. A to the power n minus 1 minus B to the power n minus 1 into A minus B is equal to 0. So A is not equal to B. So A to the power n minus 1, A to the power n minus 1 minus of B to the power n minus 1 is equal to 0. This implies A to the power n minus 1 is equal to B to the power n minus 1. Dividing both sides by B to the power n minus 1, it will be A upon B to the power n minus 1. A upon B to the power n minus 1 is equal to 1. This is equal to A by B to the power 0. This implies n minus 1 is equal to 0. Implies n is equal to 1. A minus B is equal to 0 implies n is equal to 1. I hope it is clear to you. Is it clear? Okay, then come to geometric mean. Let me check the time. Time now 10:15 and 12. Okay. Then come to geometric mean. If ABC are in GP, then B is called geometric mean of A and C. You know, if ABC are in GP, then B by A is equal to C by B. This implies B square is equal to AC. This implies B is equal to AC to the power half, or B is equal to root over of AC. B is equal to root over of AC. So geometric mean of two numbers, thus geometric mean of two numbers A and B is AB to the power half. Geometric mean of two numbers A and B is AB to the power half. Clear? The second note point, geometric mean of n numbers A1, A2, A3 up to An is A1 into A2 into A3 up to An all to the power 1 by n. Then come to n geometric means between two given numbers. N geometric means between two given numbers. We should discuss it like a question. Insert n geometric means between A and B. Insert n geometric means between A and B. Let x1, x2, x3 up to xn B. N geometric means between A and B. N geometric means between A and B. Thus, A, X1, X2, Xn, and B are in GP, where A is the first term and the common ratio is unknown. We have to find the common ratio, then we'll get each term X1, X2, X3 up to Xn. So let R be the common ratio of the GP. So Tn plus 2 is equal to B. So Tn is equal to, in a GP, nth term Tn is equal to AR to the power n minus 1. So Tn plus 2 is A into R to the power n plus 1 is equal to B. So R is equal to B upon A raised to the power 1 by n plus 1. P is equal to B upon A raised to the power 1 by n plus 1. So X1 is equal to AR. This is equal to A into B upon A raised to the power 1 plus n. X2 is equal to AR square. This is equal to A into B upon A raised to the power 2 by n plus 1. And Xn is equal to AR to the power n. This is equal to A into B upon A raised to the power n by n plus 1. So read the question. Insert four geometric means between two and 64. Answer आया Answer 4, 8, 16, 32. Okay. Let X1, X2, X3, X4 be four geometric means between 2 and 64. Thus, 2, X1, X2, X3, X4, 64 are in GP. So 64 is equal to 2 into R to the power 5. So R to the power 5 is equal to 64 upon 2 is equal to 30. So R to the power 5. is equal to 32. R equals to 32 to the power 1 by 5, which is equal to 2. Thus, x1 is equal to here. X1 is equal to 2 into 2, that is 4. X2 will be 8. X3 will be 16. X4 is equal to 32. Okay, so the theory part is over. 25 minutes left, 22 minutes. So better to discuss some questions. Opinions. Okay. I done a question asked in JEE 2025. Find the sum of first 40 terms of the sequence of the series 1 plus 3 plus 5 square plus 7 plus 9 square ଦୁଇଟା ପିଲା ଅଛନ୍ତି ଦୁଇଟା ତିନିଟା ଆଉ 5 ମିନିଟ୍ କରିଦିଏ ଆগে ସବଜେକ୍ଟ ଏକ୍ସପର୍ଟ ଅଛନ୍ତି Yes, I think Gayatri has sent the answer. Yes, 41880 is the correct answer, Gayatri. This can be written as 1 square plus 5 square plus 9 square up to 20 terms plus 3 plus 7 plus 11, 20 terms. Okay. This is equal to sigma r is equal to 1 to 20 4r minus 3, sorry. 4r minus 3 whole square plus sigma r is equal to 1 to 20 4r minus 1. This is equal to sigma r is equal to 1 to 20 4r minus 3 whole square plus of 4r minus 1. Okay. Now I can handle this. So guys, your today's session is over. Okay. Vijay sir, namaskar.